present. Okay, okay. So good afternoon, everyone. This is the first time that that hosted by the CMU, and the first speaker for this month is come from Chulalongkorn universities, and the topic is about the regional convergence and spatial dependence in Thailand, global and local assessments. So you have like it's feel free, you can take any, but we have 1 hour for presentation and Q&A. So you can have like 30 minutes or 40 minutes to present your work. And after that, we may have I will open the floor for everyone to ask any questions or share some idea about the work. So this is the working paper, right? Not published yet, right?
It's already published.
Oh, it's already published. Okay, maybe we can share some idea for improve the paper and get the new one. I think for the futures. Okay. Okay. I will give the floor to you. You can start now.
Thank you very much. Good afternoon, everyone. It's my pleasure to speak to you in this fallback seminar today. And my name is Katikar Tipayalai. I'm a new lecturer from the Faculty of Economics, Chulalongkorn University. And as the topic of my presentation today is related to the exploratory data analysis using map. So prior to my talk, please allow me to show you a very short video presentation. How can a Williams maps can help us save the planet.
It's all happened here. Everything we've ever known, done, loved, took place on this drifting, spinning ball that's our home. It's where we learned to provide, nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction. This morning. The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.
All right, thank you very much. So let me begin my presentation now. So the topic of my presentation is regional convergence and spatial dependence in Thailand, global and local assessments. Actually, this is the paper that I wrote with Professor Carlos Mendes from Nagoya University. In case you would like to see the full article, it was already published in the Journal of the Asia Pacific Economy. So please feel free to take a look at it. And in this presentation, I will cover 4 main points. The first is summary of the research. Second, data and methodologies. Third is the results of the paper. And finally, concluding remarks. So that would be the overall structure of my presentation today. And now let's move on to the first point. So here, I would like to give you a brief summary of this research. As we all know that uneven development across region has long been a significant characteristic of the Thai economy, suggesting that there is a large regional disparities in Thailand. However, regional economic disparities have not yet been much studied, especially at the province level. Also, most studies tend to investigate the regional disparity and convergence by means of the using of the traditional convergence framework, such as beta and sigma convergence, which actually only try to describe the behavior of an average economy. However, they often ignore the important factors such as individual heterogeneity, multiple equilibrium, local convergence clubs, or different characteristics among factors. So in this study, we aim to evaluate and also re-evaluate the regional convergence hypothesis across provinces in Thailand, considering local convergence clubs and the role of spatial dependence. So for the method we use, we began with the most standard economic convergence indicators, which are beta and sigma convergence, in order to identify the global convergence. And next, we applied club convergence analysis of Phillips and Su 2007 to identify the existence of local convergence. And then we applied the exploratory spatial data analysis to identify both global and local dependence. And the only data that we use in this paper is the real GDP per capita at the province level, or we can call GPP per capita, which was obtained from the Office of National Economic and Social Development Board of Thailand, or ESDB. And this study will cover 77 provinces in Thailand, starting from 1995 to 2017. And there are three main results of this study. First, on average, there is a presence of an overall sigma and beta convergence across provinces in Thailand. However, when we study beyond the average, we found that there are three convergence clubs, and each club are converging to a different steady state. And third, spatial dependence across provinces plays a very important role in the formation of the convergence clubs. So for the contributions of this research, are threefold. First, this study constructs a novel province-level data set of per capita income for all the 77 provinces of Thailand over the period of 1995 to 2017. Second, in addition to the traditional convergence methods, we apply the more recent convergence frameworks of Phillips and Su to investigate regional heterogeneity and patterns of club convergence. And third, we extend the analysis with an application of exploratory spatial data analysis, or ESDA methods, to examine the role of spatial dependence in the evolution of regional inequality and convergence. And before I start talking about the methodology, this figure provides an overview of our research objectives, questions, methods, and workflow. So here, as you can see, that we try to analyze in two steps. The first step, we first explain two methodologies to study related about the regional convergence analysis. And here, as we mentioned, that this paper will explore at both global and local level. So in each step, we try to identify in both levels. So here, the regional convergence analysis at first level, at the global level, we use the global convergence analysis. This is the classical traditional convergence analysis, where we try to answer the question that is whether the GDP per capita of poor regions is actually growing faster than the rich regions, and also whether the overall dispersion of GDP per capita is decreasing over time or not. And for the local level, we use a club convergence which is a local convergence analysis, we try to answer the question whether there is an existence of convergence clubs of GDP per capita or not. And next, we then describe two methodologies to study the spatial dependence at the both global and local levels again. For the global level, we aim to answer the questions whether there is an overall pattern of spatial clustering in GDP per capita or not, and also whether spatial dependence is decreasing or increasing over time. And for the local level, we try to identify whether where is the location of the spatial cluster. So these are the main research questions in this paper. So now I would like to talk about the methodology that we use in more detail. The first method is the classical convergence, which has widely and commonly been used for many studies related to convergence. The first one is beta convergence, refers to a process in which backward or poorer economies tend to grow faster than the advanced or rich ones. Therefore, it can be defined as a negative correlation between the initial income level and the income growth rate. So the following, So as you can see here, the following regression equation shows how beta convergence can be examined. So you can see that the annual growth rate of the national log of economic output measured by income per capita is regressed over the national log of income per capita in the initial year. So if the initial poor provinces grow faster than the initial rich ones, then there is a presence of beta convergence. Therefore, a negative and significant value for beta implies the presence of beta convergence. Oh, and in terms of sigma convergence, which I didn't show here, sigma convergence basically has also been used to determine whether the growth of per capita income across provinces in Thailand have decreased over time. Or in other words, income among provinces becomes distributed more evenly or equally. And as the classical convergence, as I mentioned, give only a single result for the entire data set, they may hide some more complex local dynamics. Therefore, in this study, we apply the club Phillips and SWU. So as I mentioned earlier that we use the method that proposed by Phillips and SWU here, in which they aim to test the convergence hypothesis of the nonlinear time-varying big factor model and the clustering algorithm. So let's begin by the first equation that they use the panel data, then they first decompose these equations. So here, Yij refers to the GDP per capita. In this case, we use a GDP per capita at the province level of Thailand, and I is a region and T is time. So for the theta IT, it represents the permanent common components, where the epsilon is the transitory components. And in order to separate the transitory components, the above equation, we transform them in the form of the dynamic factor. So here we'll multiply by mu IT and divide by mu IT, and then we get the log YIT with this equation here. So now we get, if we group this equation here, we get the new variable, we call it a delta. Delta IT here is a factor loading coefficient that represents the individual distance between a common long run trend. And now we have a mu T, which is a common component. And we also then model the relative transition parameter as a HIT by removing this mu IT. So basically we just divided by the all the so here we got this. This is the relative transition parameter as H here, and then we got this equation after we divide by the average of the log GDP here in both sides. And now, as if T converges to the infinity, now we got the convergence can be defined as this equation. So in other words, from this equation, we can see that when the relative transition parameter converges to unity, or this H, which is the relative transition parameter H, if it's converged to unity or converged to 1, then you will get that the cross-sectional variance converges to 0, or HT is converged to 0. So what Phillips and Su proposed is the following log-T regression model in order to identify or test the hypothesis of convergence here. And you can see this is a log-T regression model, and I will not tell you in the description, but from this model, we test the hypothesis of convergence, and the null hypothesis of convergence will be rejected if the TB here is less than minus 1.65. However, and when the null hypothesis of the overall convergence is rejected, it means that the methodology will allow us to identify that there are more than one convergence clubs independent. So in the results, I will show you how we can identify the possible convergence club in our data set. And next, here, I would like to now talk about the global spatial autocorrelation. The reason that we apply this model because the previous analysis, as we mentioned, that it may not cover all the significant geographical locations and patterns of the economic distributions that may change over time. So we then further explore the spatial autocorrelation. And the first spatial autocorrelation at the global level is called the global spatial autocorrelation, which indicates the overall clustering of a variable in space. So it will capture the magnitude of linear relationship of variable, and in this case is a GDP per capita at one location with the spatially weighted average of values at neighboring locations. So the widely used tool for examining spatial autocorrelation is called the Moran's I statistic, as you can see here as the shown following equation. So in this equation, you will see that I is a Moran I statistic, Moran I, and N is the number of our observation. And here in this case, as we use the provinces of Thailand, so it's 77. So I will talk a bit more about the spatial weight matrix here, which is an important factor that we have to identify in order we can compute the Moran's I statistic. So to calculate the weight matrix, since if someone who also work in the spatial econometrics will know that we need to identify the weight matrix, since it can be calculated based on several criteria. For example, spatial contiguity, distance threshold, inverse distance, and k nearest neighbor. So I will talk a bit about how can we identify the spatial weight matrix here. So since there are different ways to identify neighbors, so but the most common way to identify the weight matrix is the contiguity way. Contiguity is a common boundary. So we will ask like, what is our shared boundary? So here, the contiguity can be defined by the neighboring places, whether borders are connected, vertices or corners are connected, or both. And usually we can define them into three main types here, which actually is represent from the how the chess pieces are moved. For example, right, rooks, bishops, and queen. So the first one is rooks. For example, the weight matrix here, I will begin with a 3 times 3 matrix. So if our interested matrix, for example, our focus or our observed province would be the center here. I put it as a square box here. And if you want to define the spatial weight matrix by using the rook contiguity, the rook contiguity means that as the chess piece move for rook is only the neighbors that you chess by the border are included for the rook contiguity. However, for the bishop contiguity, we only focus on the corner one, the matrix or with vertices one here. However, for the queen contiguity, it's a combination between of rook and bishop. So for the queen contiguity, so we consider all the neighborhood that are connected to the province that we observe. So both borders and vertices are included. Moreover, apart from the contiguity, weight matrix, we also have the distance weight by using distance band or k-nearest neighbors. So if you use distance, for example, some countries that, for example, the Philippines and Indonesia, that they have so many islands, it will be really difficult for them to identify by using the contiguity, because some provinces of them are not connected. They are separated by seas, area. So in that case, they will use the distance neighbor in order to identify the weight matrices. So they will ask how many neighbors to include, and what distance do we use in their study. For example, like within 100 kilometers or 200 miles, for example. So that's the way that we can identify our spatial weight matrix. So if it's the Bij will be equal to 1 if I and j. So I, if it is our focus province, and j, they are neighbor. If our focus province and the province that are connected to our focus province are neighbors, we give it as 1, while the 0 for the otherwise that they are not connected. So here, as you can see, how can we calculate the weight matrix here? We then are able to calculate the Moran's statistics. And for the value of Moran's are between +1. For +1, we will get the positive spatial autocorrelation, and -1 is refers to the negative spatial autocorrelation, while the values that close to 0 will indicate the distribution random across space. And here, the next method that we use is a local spatial dependence analysis. It classifies the location of the spatial clusters and outliers. So in particular, the local Moran's here classify regions into 4 groups of cluster. The first one from this result, so actually the local Moran's is based from this one, the global Moran's but the global Moran's you will get the results in the number. But in order to find the location, where is the significant, where is the cluster of the location, so we need to use the local Moran's So for here, what we get is we will get the 4 groups of clusters. The first one we call it as a high cluster. This will represent a high income regions that surrounded by neighbors with also high income regions. Second, we have a low cluster, which represents a group of low income regions but surrounded by the low income neighbors. And third, we have a high-low cluster, represent high income regions but surrounded by the high income regions. And the last one is a low-high cluster. The low-high cluster is a low-income regions but surrounded by high-income neighbors. And the first 2 clusters, which are high and low one, it identifies the location of spatial clusters, while the other 2 clusters, high-low and low-high, can identify the location of the spatial outliers. So now I would like to move on to the data that we use here. As I mentioned earlier, that we use the annual data on GDP per capita at the provincial level, or GDP per capita for the total 77 provinces in Thailand from 1995 to 2017. And it was obtained from the NESDB, which is the official government organization. And however, there's a problem here, since there are some missing values of the newest 77 province in Thailand, which is Bungtan, which was partitioned from Nong Khai province in 2011. And since the method of Phillips and Schultz that we use here require balanced panel data set, therefore, in this study, we need to construct the data for new province by we use the interpolation and imputation approach, which was actually previously conducted in the study of Kernel 1, 2019 for the case of Indonesia. So the interpolation of the new province can be done by just basic linear regression, and using the reference province, here is Nong Khai, as regressors. So this table will present the descriptive statistics for our selected year, since we use the long panel data from 1995 to 2017. But for the descriptive statistic table, we only pick some year, the initial year, the middle, and the final year. So we have like the three GDP per capita in 1995, 2006, and 2017. And the first three rows show the descriptive statistics of the real GDP per capita. On average, income per capita appears to be increasing over time. And in terms of dispersion, the standard deviation is also increasing over time, showing that there is a large regional disparities in per capita income across provinces in Thailand. And here you can see that in 2017, the real GDP per capita of the richest province is almost 20 times higher than in the poorest province. So also the fluctuation of the GDP per capita can be seen in the interim years between 1995 to 2017. So it suggests us that it's necessary to use the natural logarithms as our estimations. So when we use the natural log of GDP per capita, it appears that while the mean of log GDP per capita is increasing over time, the standard deviation is, however, decreasing over time. So this is also similar to when we generate the log GDP per capita in relative to the mean of the selected years. Therefore, it suggests that there is a sign of sigma convergence here. So next, I would like to explain how we can identify the spatial connectivity in Thailand for the purpose of conducting spatial weight matrix in the spatial dependence analysis. So normally, if all regions within a country have connected boundaries, we might not need to construct the spatial connectivity structure. However, in case of Thailand, the administrative boundaries in terms of the Thai provinces are not entirely contiguous on the map. That is here, the small island of Phuket province is actually separated by water. So due to this lack of geographical contiguity, the Queen contiguity criterion, the neighbors of a region that share both boundaries and corner, which is actually the most frequently used method for determining geographical neighbors, is inapplicable here. Therefore, we need to employ the computational geometry approach. So in step one here, we try to point out the polygon centroids of the, and then in the second step, we take the centroids of the administrative boundaries, and we take the centroid of the original administrative boundaries, and then we generate the contiguous new polygon structure here. So actually this construction framework can be also known as a descent polygon. And later in the step T, we can connect the entire regional system. And finally, in the final step, you can see that we can now identify the neighbors of each province. So now all the 77 provinces in Thailand are connected, and we are able to use the Queen contiguity matrix. All right, so for the results of this study, this slide shows the results of the first method that we use, which is a global convergence analysis in terms of beta convergence. And figure 4 here, it illustrates the graph of the growth and the initial level regression of GDP per capita for the total 77 provinces of Thailand over the year 1995 to 2017. And the result here, as you can see, that it suggests the evidence of beta convergence, as the coefficient of this regression is negative and highly significant at the 1% level. And this implies that the initially poor provinces here are growing faster than the initial rich province in Thailand. So suggesting that the existence of beta convergence. And the second convergence concept that we measure is sigma convergence, which is related to the decline in the dispersion of income per capita. And as you can see from this figure, it shows the long-term trend of the decreasing per capita GDP per capita in dispersion in Thailand, as measured by the SD, standard deviation for the log GDP per capita. However, as you can see from the graph, there is a slight increase in income dispersion during the end of the given time period. And the most rapid period of sigma convergence was in the late 2000s here. So also the coefficient of beta, of sigma convergence is also negative and very highly significant. So it shows that there also an existence of sigma convergence here in during our period of study. Next, we analyzed the global spatial dependence in order to identify the neighboring effect, which is the outcomes of neighbor regions can affect the outcome of the origin region or not. So table 4 here shows the results of the Moran's I values for the GDP per capita in both initial year and the final year. So in order to make sure that our Moran's I values are robust, therefore we will not use only one spatial weight metric. So we compare all 5 different spatial weight metrics here, as you can see, roof, queen, nearest neighbor, and also the distance band. So, but overall, you can see that the results of our global Moran's I give the positive spatial autocorrelation and also a strong evidence of the spatial dependence, where Moran's I statistics are highly significant at the 1% level for all years. So later we also try to show you the dynamics of the global spatial dependence in this figure. As you may see that although the degree of spatial dependence may decrease over the period of the study, the dependence is still high, significant over time, in which the spatial patterns of the income dispersion in Thailand by nature tend to be clustered or agglomerate together. So there are 2 possible reasons that can explain this decreasing trend of the spatial dependence. The first assumption that we thought is that a decrease in spatial dependence may be due to the fact that regional clusters decrease during a period of decreased income dispersion. And another assumption is that the income levels of the provinces in each clusters are becoming less similar. So that's why we have a result in the decrease in spatial dependence here. And in order to support our latter argument, so in this figure on the right side, we present the transition of the parts of GDP per capita for all 77 of Thai provinces here. And it can be seen that, as you can see, that all the provinces here, 77 provinces, they are not move into the similar, merge into one cluster. However, they tend to move towards their regional cluster that's similar to their neighbors. So this also suggests us that by focusing on the global measure of regional convergence and spatial dependence may not be enough, and it may hide a more implicit consideration of spatial dynamics and may also fail to determine the individual characteristic across Thai provinces that possibly can affect the economic growth process in Thailand. Therefore, we then turn to a local aspect of regional convergence and spatial dependence here. So by applying the Phillips and Zhou log-T regression test, in order to identify the existence of convergence clubs of the GDP per capita here, this table reports the results of the log-T convergence test. And here the coefficient of the log-T is less than 0 and equal to minus 0.36, and T-stat is equal to minus 13.92, which is less than minus 1.65. So for our null hypothesis, then if this T-stat is smaller than minus 1.65, then it's possible to say that we can reject the null hypothesis of full convergence, which suggests that all the provinces in Thailand do not converge to the same steady state. However, there might be some kind of further the existence of some local convergence clubs. So here, since the null hypothesis of overall convergence is rejected, we can now test the existence of the local convergence clubs. And table 6 here shows the results of the log-T test of the convergence for local clubs. And it suggests that the development of per capita income in Thai provinces can be grouped or classified into 3 common subgroups or local clubs. The Thai provinces can be grouped into 3 local clubs, as I mentioned. However, as noted by Phillips and Su, the clustering algorithm somehow it overestimates the actual numbers of clubs. So we need to apply the merging test procedure in order to identify whether there are any of clubs can be merged into form a larger or bigger clubs. So we try to merge between club 1 and club 2 and club 2 and club 3. However, the results here of the merge test, and you can see here that both of T-stats in the both merged clubs results in minus 6.52 and minus 4.84, which both are smaller than minus 1.65. So these results suggest us to reject the null hypothesis of convergence. Therefore, the initial 3 local clubs here cannot be merged into 2 larger clubs. So we try to elaborate more of the results of here of the Phillips and Su local club convergence. So we chose the dynamic growth transition part of the per capita GDP of 77 Thai provinces, which can be sorted into 3 common trends here. The convergence club are ranging from the group of the, as you can see here, with the highest GDP per capita to the group of provinces with the lowest GDP per capita. And here we found different transition patterns within each club that reflects the difference in economic development patterns or process of Thai provinces. And in general, the provinces that below the average level mostly tends to move to the upward and catch up with the higher income provinces within their own clubs. While there are some provinces that are not changing over time here as well. So in addition, when we focus on the mean of the convergence club, so we put it together and identify the mean or average of the log GDP per capita in each club. And we represent here in this figure, you can see that these figures suggest that the income gap between clubs are extremely large, particularly in the between club 1 and club 2, and also in club 1 and club 3 as well. And the average GDP per capita of provinces in club 1 is approximately 4 to 6 times higher than those in club 2 and 3 respectively. So this also highlights the problems of the unbalanced economic growth and income disparity among Thai regions. So, and according to the results of our local convergence, we put them into the map so we can easily see where is the location of each club, local clubs in Thailand here. So the first convergence clubs or club 1 in the red color here, it consists of 12 provinces, and club 2 in the orange color consists of 48 provinces, and the third club in the blue color consists of 17 provinces. And provinces in the high income clubs tend to be those in Bangkok and the vicinity and around eastern part of the country. However, provinces in the low income clubs are those located at the border areas in both northern and southern part, specifically Narathiwat, Pattani, and Yara, where they have long been suffering from political conflict and fragility. Moreover, more than half of all Thai provinces are found in club 2, dispersed in most parts of the country. So we further deepen this convergence club analysis by using the means of using the traditional beta and sigma convergence analysis again. So figure 11 and 12 here presents the results of sigma and beta convergence within each club. Here we can see that the evidence of both sigma and beta convergence in this club so support our findings of convergence club. The result implies that per capita income tends to converge to the same steady state when a group of province shares some common conditions and characteristics. This analysis emphasizes that although poor regions are catching up with the rich ones, economic growth across different areas of Thailand is still uneven. So in order to further clarify the persistence of an economic disparity does not only happen among, but also within the regions, we then employ a local spatial dependence using a local indicator of spatial association to identify the location of the high and low income clusters. And here, figure 13A and B show the significant spatial clusters in the initial and final years of the study. So some key points can be mentioned here. The first one, the global patterns of positive spatial autocorrelation are reflected by the local patterns of the spatial dependence, where there are only two dominant spatial clusters, which are high in the red color, or we can call it hotspot, and also the low clusters, or we call it whole spot in both years. And second, the spatial clusters of the high income provinces in red color have been mainly concentrated in the capital city and around the vicinity, and in some provinces in the central and eastern parts of the country. And for the spatial cluster of low income regions in the blue color here are mainly found in those provinces located in the northern and northeastern regions of Thailand. And finally, we observe that the clusters for the income per capita are highly persistent during our period of study, with only some indication of a lower degree of spatial dependence. For example, some provinces in the northeastern region are in lower cluster in the beginning year. However, it no longer exists during the final year in 2017. Also, there are some new provinces in the high cluster in the final year, and suggesting us some evidence of the hotspot expansion. And I guess I'm running out of time. So for the conclusion, as I mentioned in the beginning, that our study aims to identify, to evaluate the regional convergence hypothesis across regions of Thailand. And based on our findings, we found out that on average, there is an overall convergence across Thai provinces over 1995 to 2017. And the presence of beta convergence suggests that initially poor provinces in Thailand are growing faster than high income provinces. And also the evidence of sigma convergence implies that regional dispersion of GDP per capita is also decreasing over time. However, when it comes to beyond average, we found 3 convergence clubs, and in which each club tends to converge to different steady state. Therefore, this implies that an excessive focus on global convergence can be incomplete at best or misleading at worst, and that spatial dependence can play a very important role in the formation of the local convergence clubs. So regarding to the evolution of the provincial income distribution, there are significant co-movements between a region and its neighbors. Moreover, these co-movements are more frequent in high income and the middle income clubs. And finally, according to the spatial distribution of the convergent clubs, here, the major impediment for achieving regional income convergence in Thailand has still long been the prolonged existence of the regional disparity gap. And that is all for my presentation today. Thank you for your kind attention.
Okay, thank you so much for your very interesting talk here. And okay, as you still have time to like let's say not Q&A, but just discussions or any like suggestion to improve this good paper, I think. Okay, so anyone, do you have any comment or suggestion for this talk? Let feel free to have. Okay, so you can have, yes.
Yes. Okay. Let me take a shot at this. Yes. Again, thank you for presenting the paper. Actually, I am aware of what you have published and a few points. Can you hear me? Yeah. Okay.
Yeah.
I also do some work on convergence, and one of the big issues that I have is that I still find that the measures, the beta and sigma converges, have got a lot of problems. And in fact, I published a paper a few years back. Maybe I'll put the link for you later on the chat, which criticizes these two measures because they sometimes confuse between, let's take beta, for example, just the beta, the beta, which is the OLS coefficient, which is made up of two parts. It's made up of the correlation coefficient between two time periods, as well as the ratio of the standard deviations. So in a way, it's not really measuring convergence as in the typical sense that there's going to be less of a disparity, or shall I say, poorer places are getting more richer and richer, perhaps, that kind of, somehow it misses the point. And that's something that I've always been critical about. And then we have this sigma convergence, which you are talking about. And the problem with that is that it doesn't account for the rankings. It just looks at the dispersion. You can have a crisscross of rankings. And so there is, in the literature, I think you can find this, it's called gamma convergence.
Right.
Yeah. So gamma convergence, which is basically based on the Kendall W statistic, will actually look at the ranks as well. So I think that's something that you can explore, because I would presume that on a global scale, maybe the ranks will remain more or less similar. But when you talk about in provincial scale, especially maybe in certain clubs like you're looking at, the rankings can change quite. The ranks can change, I think, a little bit more than if you just look at global scale. So maybe taking a look at gamma. Okay, so just two questions on top of this. Is that okay? First, I like the way that you split everything into clubs and try to see how convergence is playing out in those areas. One question I have is can you correct me if I'm wrong, but these clubs are not constant throughout the period, right? So the provinces, some provinces are coming in and some provinces are also going out, right? Is that correct? And if that's the case, I just want you to clarify how that is possible, because you put a weight with your spatial matrix, you put a weight. So is that also time varying? That's what I want to know. That's my first question. Yeah. So are the weights time varying? So that's my question. Because I don't know how you're able to switch regions in and out of different clubs. But I thought that was a nice addition to the discussion. Yeah. So maybe you can give maybe just to give a very short comment. You can give some elements of what are the reasons for people going into different clubs? Do you think it's just the geographical distance, or there are other shocks? For example, if COVID happens, which has happened, would that affect people, provinces moving across the clubs? Those are my two questions. Thank you.
Thank you, Ajahn Yun. That's very interesting questions. Yeah, I concern that there is some problem related to the classical convergence by using of beta and sigma convergence. That's why in this study we try to investigate further than apart from the classical convergence part by using the Phillips and Su convergence part, because we also think that only the classical, the average of the rich tends to growing fast, the poor tend to growing faster than rich provinces, or even the dispersion of income are decreasing over time are not enough. So that's why we try to identify further whether the normally the provinces, a group of provinces in Thailand tends to decrease or catching up together by the separate groups or not. And also our results from this study prove that the provinces of Thailand actually they are growing as a group. So they tend to merge to the similar, and this also reflects us that, oh, maybe because of the different characteristics of province. For example, we cannot compare Bangkok with Pattani. So it's totally different. So as this study that we found, it proves us that the spatial dependence and the spatial autocorrelation are important. Later when we implement the policy, we have to also concern about the spatial dependence as well. Yes, and also the gamma regression. You also mentioned same as the reviewer asked us to also cover with the gamma. So we also put some definition of the gamma convergence in our literature review as well. But here, that would be the good thing that we will cover in our next paper. Yes, by using the gamma convergence. And in terms of the local convergence, autocorrelation, let me show you here. Yes, we also concerned that because in different periods, it shows the different groups of the hotspots and cold spots. And that's why later, I just found that there are now not only the exploratory spatial data analysis, but now the new study, they try to measure the what they call exploratory space-time data analysis. Now they will see, because then they think that this kind of results show only capture of time. So only 1995 and 2017. And what about the in-between periods? What are the movement of the regions inside that country? So that's why they have now the exploratory space-time data analysis, that they try to mix between this kind of local spatial dependence together with the what they call directional statistics. So what they will give more, in which I think I will do in the next paper, what they do is they try to find out. So during this period, you will see the direction of whether, for example, here in the, let me use data point. So for example, here, if during 1995, these provinces are in the low or cold spots or low clusters, you will see the trend. You will see it as the direction. So they will give you an arrow that will show you that whether from this period to this period, what should be the direction of this one? It can be that, okay, this is really decreasing from low clubs, they tend to decrease more. So I think that would be great that in our next paper, we will show the more dynamics patterns of the spatial cluster here. So thank you very much for your question.
Okay, anyone else? Do you have anything to share with Ajahn Katikar? No one. So maybe I can have like, because the paper is published already, so I don't think that I need to like to comment much here, but just maybe some suggestion a bit for maybe you can use in your further works. But I have a few questions a bit. Maybe I confused, but I'm quite not sure. Maybe you can clarify a bit for me before I give some suggestions. I have looked at the result of the beta convergence that you provide in the first figure, and it seems that it have negative, right? And it is negative, so it means that it has some convergence in Thai province, right? Yeah. But in the later slide, you mentioned that when you plot the GDP per capita of all provinces together, it seems to have like club convergence, like you mentioned. So and I agree with that you have a club convergence. So I'm not so sure. Maybe I missed something here, but so if it has the club convergence among the 37 provinces, so why the beta have a negative slope? It should be like not have convergence in the overall. maybe you can go through the yeah, like this one. This is the data along 1995 to this, right? So this is negative, so it means it's convergent already at the beginning, but in the later it have a diverse, like convergence happened when you plot the graph with the GDP per capita together. So like this one, yes. So I wonder that why this thing happened. Maybe I missed something here. Maybe you can clarify a bit for me.
Yes. Yeah. So actually, the previous graph I try to show you the this is the sorry here. So this is a lot of since the beta convergence, we try to compare whether the poor regions the initial year. So this is the relationship between the initial year of log GDP per capita together with the growth rate. So in this graph is the growth rate. So here, if you see the negative here, negative of the beta convergence, it shows us that for example, if one province which is tends to be have a low GDP per capita in the beginning year. So here beginning year is 1995, as you can see here, right? Let me show you. So the difference between convergence, again, it shows the relationship between the log GDP per capita in the beginning year. So in this case, it's 1995, and the growth rate for all the period that we studied, 1995 to 2017. So if we got the negative results, it means that the initially poor region, so it tends to be on this side, right? And the rich regions at the beginning year, should be on this right-hand side, right? So if the low GDP per capita in the initial year has high growth rate, so see, it's higher growth rate that compare with the initially high GDP per capita in the initial year, the growth rate of them is lower. So you will get this kind of graph, right? So this means that the poor provinces is catching up or grow faster than the rich region. So this is a bit different from this graph. This graph, I try to show you the transition or the trend, just the trends of the GDP per capita. So as you can see here, this one is the all year of a study. And we just only use the log GDP per capita, which is not the growth rate. So this is not the growth rate. This is only the log GDP per capita throughout the period of our study. So that's why you will see that the trend, the transition trend is not, it's not fluctuate very much. It's only tend to be constant, and you see only some provinces that have a very drastic change in that movement across the years. So yeah, so that's why the difference with the graph, so here they are different. So this, although our study shows that there is a beta convergence, but when we look throughout our period, you can see that the trends of the parts of the GDP per capita across the years, you can see that there tend to be try to converge. They tend to converge into particular groups, but not converge to the same steady state. So I hope that this may answer your question.
Yeah, but that is what my concern here, that is seem to be like the result is conflict to each other. This is what I think. But I don't know that it's okay. But it's, I think it's okay. But in my opinion here, it's just like if we take into account the whole period, the whole time, it have a club divergence, it club convergence. But if we take into account another approach, it have club convergence. So it is why that I think that the result is a little bit conflicts here. But I don't know. But it's okay that maybe that one is.
Maybe that's due to because if we study on average of the convergence, yeah, it may also suggest that okay, Thailand has, if you look only on the average of all period of the GDP per capita, the results show us that yes, there is a evidence of both beta and sigma convergence. But however, when we try to study beyond the algorithm, it also shows us that, oh, actually, yeah, the beta convergence, it appears. So that's why after we classify the convergence into the clubs, so into 3 clubs, and we then re-evaluate the beta and sigma convergence again. And as you can see here, that beta convergence for each club of Thailand, to better identify, you can see that, they all have the beta convergence again, but they have the beta convergence within their own club. Yeah.
And how do we know that we have only 3 clubs here? Can it be 4 or 5 or 6?
That's right. So that's why we use the log T convergence test from Phillips and Su, as I mentioned. But first, we need to check whether it can be identified new clubs or not. Because some countries or some data sets, when we use the convergence test result, and if your T stat is bigger, is smaller than -1 point, is bigger than this one. So it means that the null hypothesis of convergence is accepted. So that means that we cannot classify them more into the club convergence, and we cannot use this result. So we check it first, that whether our data set can also be grouped or not. So if the results can find out that yes, there is the club, there is our null hypothesis is rejected. So it suggests that yeah, now all our data sets or the provinces in Thailand, they do not converge to the same steady state, and then we need to explore more. So that's why after that, we also use the log T test to identify how many clubs that we have. And we check that it found out that we have 3 clubs in case of Thailand during our period of study. But as you mentioned, yeah, somehow this Phillips and Su model, the algorithm, somehow it's overestimate the actual number of clubs. So we need to also apply the merging test to check whether the clubs can be merged to form a larger clubs or not. So we check if club 2 and club 1 and club 2 can be merged together or not, and club 2 and club 3 can be merged or not. But however, our result, the T-stat about smaller than -1.65, so that our null hypothesis of convergence is rejected. So it said that we cannot merge the clubs. So we have only 3 clubs here to confirm. Yeah, and yeah, I hope.
Yeah, that this one I really appreciate about the method that you use here. But it mentioned it used clustering algorithm. So maybe the clustering here may be different from my understanding, or because in the data science analysis we have like many methods for do the clustering. So that's why I want to understand this one further, how they do the clustering here. That's all. But it's okay to have 3 clubs, and it have economic meaning as well. I think it's nice that you have only 3 clubs. But if you have like 4, 6, 7 clubs, maybe there are no economic meaning, I think.
Right. So, some paper in case of Indonesia found that they have like 7 clubs.
Yeah. Maybe there are no meaning. I think it's a lot too much.
Yes, to have many clubs as well.
Yeah.
But in this case, since they have like only 3 clubs, so I think as you said, it quite easier to explain by just saying that okay, the first club, which is only some small provinces, not many provinces in the first club, and you can also say that there are high income clubs, and for the second, you can even say that the middle income clubs, and the last one, it should be the low income clubs. Yeah, as I put it on the map display here. Yes.
And in the the beta convergence that you use the regression model or spatial regression model?
The beta convergence that I use is a classical traditional one, so it's a regression model.
Maybe I think that the paper may become more novel. Maybe you can you may compare the spatial approach with the classical approach along this investigation. Maybe it can make the reader to believe in the result, and if you get it's like the robustness check to check that the result remain the same compared to the classical or not, and and maybe the spatial regression may be the good one to be used here to understand like the beta convergence as well. But just a suggestion for you to do, because you work on spatial a lot, but so the beta convergence should be spatial as well. This is what I think. That's all. Okay, this is all of my suggestion here and my comment here. I don't know that anyone here, do you want to share about this paper? So Ajahn Katikar can have like the very good new paper in the future. Anyone, do you have? Ajahn Jessica, do you have? Ajahn Paul, are you here? Do you have anyone? Maybe no. Okay, I think it's about time now. It's 1 hour or 8 minutes. Okay, okay. So maybe the next round of the Bowback will be take place on next week, right? 27th at the same time. So the next speaker is I have to look at his name. He's also Ajahn, right?
Quentin, right, Jessica?
Yeah, so I can say a couple words. Next week, we have actually a foreign guest coming, Dr. Quentin Littman from University of Essex, if I remember correctly. He's an economic historian and has kindly, I've been kind of in contact with him about his research over the last year, and he was interested in presenting. So it'd be wonderful if we can get a good group of people to come and support him. His work is going to be on marriage markets and preferences for partners and how that's changed over time. So.
Yeah, I just see that the topic that he will talk is the hierarchy of the partner preference, maybe the behavioral economics, right?
It's sort of labor-ish. You could think of it in terms of behavior as well, but it is a subsection of labor economics. So.
Okay, it's labor. Okay.
Economics and economic history as well. So.
Okay, so okay, so if you are interested to join this talk again, okay, you can have like the register again and you will get the link Zoom like today. So I think maybe today is enough. So I hope to see all of you again for next week, right? Okay, next week, and about the another interest talk for this month. Okay, maybe I give back the floor to Ajahn Paul. Okay.
Thank you, Ajahn Bodh. It's a pleasure to have Ajahn Katikar and have both Ajahn Bodh acting as our chairman here. Well, thank you, everyone. See you next week. We have an interesting speaker coming.
โอเคครับขอบคุณทุกคนนะครับแล้วเจอกันสัปดาห์หน้า